Hello friends, welcome back, and in this video we are going to discuss the code example for the dependency inversion principle. So in this series, in this playlist of solid dose principles, we have already discussed the theoretical portion for the dependency inversion principle. But here in this video we are going to see some code example like what kind of code is violating the dependency inversion principle and what is the solution for that. So let me remind you the basic information related to the dependency inversion principle. So dependency inversion principle says that high level modules should not depend upon the low level modules rather than classes. The correct thing is modules. They should be depending upon the abstraction. This is the first thing. And the second condition is that abstraction should not depend upon details, which means that if you have created any abstract class, then it should not be depending upon the details that those classes are implementing, which will be inheriting this abstract class. But details, which means the classes which are inheriting this abstract class, they should take care of the abstraction layer. Whatever has been defined in the abstraction class, based on that, they should keep their implementation intact, right? So this makes the code easier to maintain, right? And how it makes it easier to maintain, and if it is not done, then what kind of problems are there, that we are going to discuss in this particular lecture. So I have written some low level classes. Suppose you are creating an application and that application is doing many things that has some particular business logic, but ultimately the business logic are executed at the a low level as well, where the information is stored in the database, where the information is sent over the network, where some of the crucial information related to the your application logs, they are written into some of the log files, so that later on you can analyze your code. So all those things are done through an application. So all those low level things like writing to the database table, writing to the log, and sending the information over the network, for that I have written three classes. These are the low level classes: write to db, write to log, and send over network. And then there is a high level class, which is demo application, which is doing something. And in this application I have taken three pointers. First pointer is the pointer to this write to db class object. The second one is write to log, and the third one is send over network. So you can see these three pointers I have created. Why I have created these three pointers? So that I can utilize these objects at runtime based on my needs to call some functions which have been written inside these classes, right? So there is some function which is written inside the high level class, and this some function is going to perform some business logic. And at the time of performing the business logic, after performing the business logic, it is going to store some information to the database table. It is going to store log some information to the log file, and it is also going to send some response over the network to the clients whosoever are using this particular application, right? So these are the things that we are going to do inside this sum function. This is some kind of function in the demo app. Now consider a situation that something changes inside this class write to db. Someone might be changing the number of arguments that some function is going to take, which you are calling here from inside your sum function method. Maybe the class, maybe the methods which have been written inside these classes, the writer of this class is going to change the prototype of the function. Like if it was taking 3 arguments, now it is going to take the 4 arguments, or if it was taking 3 arguments, now it is going to take 2 arguments, or any kind of change it is going to do. In that case, whatever changes will be done here, that will be the first place where the changes have been done. And after that, you will be you may need to do some changes here as well in your high level class as well, which is again violating all the above principles as well, like open close principle also it is getting violated, right? So this is not at all a good code. So what you need to do, you need to follow the dependency inversion principle. So in this situation, what you need to do, rather than using low level classes directly, there should be an abstraction layer. You need to write an abstract class. Abstract class means which has pure virtual functions which cannot be instantiated in C++. So I'm going to write one class, the writer abstract, writer abstract class, and then here I'm just going to provide the the prototype of the functions which need to be implemented by the writer functions, like writer classes, like write to log or write to db, whatever. So I'm going to do something like this: void perform write, perform write operation, and here it's 0, right? So this is a pure virtual function. So here write to db is going to write to write abstract, right? And now here what you need to do, you simply need to implement this method, right? So here you will implement this method. So whenever the application whenever the classes will be written, we need to take care of these things. Okay, so this you need to virtual, I need to write the virtual, I just forgot this. So virtual void perform write operation. Okay, so perform write operation, I have written the function here inside the write to db. So whenever the low level classes will be written, they will depend upon this abstraction layer. They need to implement based on this abstraction layer. They need to implement the functions whatever has been given here, whatever abstraction layer says, based on that they need to implement their functions. And the designers need to take care of this thing, that this abstraction layer should be designed in such a way that all the basic needs have been catered, and they all have been written in the form of the functions. They all have been given in the form of the pure virtual functions in such a way that later on the chances of doing the changes are minimal, right, or nearly 0, right? Because the basic operations, they hardly need any changes. The low level class, that is why we have talked about the low level classes. This has been written for the low level classes. Low level classes means which are doing the actual work, which are doing the actual write operation, actual sending over the network, actual db operations, all those things. So there are very less chances that you will do any changes. So whenever you are going to create, whenever the designers are going to create these classes structures, they need to take care of whole view, the holistic view of the entire application setup, and then they should write their classes. They should structure their classes in this manner, right? So low level classes like write to db, now it is going to implement this write abstract class. And similarly this is also going to do the same thing, the other class, which is the write to log. So I'm just going to do something like this, and I'm going to remove this, and same thing I'm going to do with this one, right? So write to abstract, and I'm just going to class, what was the name, let me send to network, and from here till here I need to, yeah, now it is fine. So all these things I need to do. And now what I need to do with the high level class, I need to do one thing. Rather than using these low level classes directly, I need to use this write abstract. I need to create an instance of this write abstract p writer. Okay, that's it. So now you will be using this abstraction layer. So this high level class is also using the abstraction layer, and these low level classes are also using the abstraction layer for the implementation, and the low level classes are involved here. This is the important thing you need to take care of, that this particular principle, dependency inversion principle, you need to you need to take care of when you need to implement, you need to think of when you are involving some low level classes or some low level operations like writing to the database, writing to the disk, writing to the network, whatever, right? Any low level operation. So with this, if now you have decided everything, and if you have changed anything over here, then also you don't need to test here again. You don't need to change anything here again. All the logic will be changed inside the low level classes only, right? If in future somehow this thing is changed, like any argument is added or any argument removed, in that case, what will happen, that since you are using this abstraction layer, so you will just need to worry about this thing, what it says, the abstraction, what does abstraction layer says, right? You will create an abstraction level class object, and then based on that, you will create the different objects like the write to log, write to db, and send over network. All these things you can create based on the need on the at the runtime, and then you can call those functions which are written inside this, like write to db or write to log, or write or send over network. So this way you don't have to worry about like what has been changed here, and if any arguments has been changed here, because you just have to worry about this one, what your abstraction layer says. So your high level class will also bind to the abstraction layer, and your low level classes will do the implementation based on the abstraction layer. That you need to take care of. This was all about the implementation related to the dependency inversion principle. So you need to take care of only one thing here, which is very important, that whenever the low level classes are involved, then in that case you need to take care of this particular principle, the solid oops principle. With this particular lecture comes to an end, and with this particular playlist for discussion on the solid oops principle also comes to an end. I hope you must have enjoyed it. If you have any suggestions, if you have any comments, then you can let me know. I will definitely would like to address all those. So with this particular video comes to an end. Have a nice day, and bye bye.